بسم الله والحمد لله والصلاة والسلام على محمد رسول الله وعلى آله وصحبه ومن والاه. I will talk about adding Koin dependency injection framework to a Kotlin multi-platform project. I will demonstrate the dependency injection by creating some use cases and inject them into the code. Koin is an open source dependency injection library that is written in pure Kotlin, which makes it great for us to implement in Android applications and Kotlin multi-platform projects. For more information, visit their website at insert-koin.io. To begin, we need to go to kmp.jetbrains.com and download our project setup using the KMP wizard. We select a name for our project and the project ID. Then we select the platforms we want to work with, in this case Android, iOS, and desktop, and we download the project files. We open our project in Android Studio. We switch to the project view to explore the project structure easier. In the Compose app directory, which contains the source directory, we will find the applications directories. The Android main for Android application, the common main is where we add the shared code, the desktop main is for the desktop application, and finally the iOS main is for the iOS application. To add Koin libraries to our project, we open the libraries file in the Gradle directory. In the versions section, we add the Koin version. At the time of this video was 4.0.0. In the libraries section, we add the Koin libraries, which consist of Android-specific libraries and the common libraries. We sync the Gradle file. We open the build.gradle file. In the source set block, we add the Android-specific libraries to the Android main dependencies block. In the common main dependencies block, we add the common libraries and we sync the project files again. Let's create a domain package in the common main directory to add our use cases to it. We'll create a common use case and inject it into our code. In the common use case, we will use the invoke function and print a message that says common use case invoked. We can inject any type of class. It does not have to be a use case, but we're using a use case for simplicity. To be able to inject the common use case in our code, we need to create a singleton of the use case in a Koin module. Let's create a DI package to add our modules in it. Let's create a common module file. In the common module file, we'll create a Koin module variable, and we will call it common module. In the common module, we create a singleton of the common use case using a function called singleoff. Singleoff is one of the functions that Koin provides to create singletons. We will explore other functions later. In the singleoff function, we type the use case name first and then add double colons before the name. If we add the double colons first, the use case will not be imported and we will get an error in the singleoff function. To fix the error, we add the class name first, import the file, and then add the double colons before the class name. In this example, we'll share the UI between platforms. Let's create a UI package for the UI files. We'll create a shared view model to inject the use cases that we create as parameters. Koin will look up the implementations of these use cases in its modules and pass the implementations to the parameters. We will create a function in the view model that will call the invoke function from the common use case. We go back to the common module to create a singleton of the shared view model using another Koin provided function that is called viewModelOff. Let's open the app composable to create our UI. The app composable is the entry point to our multi-platform project. Let's delete the code inside the material theme block and inject the view model into the composable using a function provided by Koin called CoinViewModel. The UI will not be complicated, simply a column that covers the entire screen and a button in the center. We use the onClick action of the button to call the invoke common use case function from the view model. To use Koin in Android, we need to start Koin in the application class. We need to create the application class in the Android application directory. The application class will inherit from the Android application class, and we will override the onCreate function to add the start Koin function to it. We need to pass the application class to the Android context function parameter in the start Koin lambda. We need to pass the common module to the modules function parameter in the start Koin lambda. If we have any Android specific modules, then we can pass them to the modules function as well. We'll explore that later. We register the application class in the manifest file, and we start the application in the emulator. We open the catalog, we click the Invoke Common Use Case button, and we see the Common Use Case Invoked message in the catalog. To run Koin in the desktop application, we open the main file in the desktop main directory. Before the application block, we add the start Koin function. We don't need to pass context, only the common modules and any other desktop modules that we may have. To run the desktop application, we open the Gradle task executor and type compose app:"run." We click the Invoke Common Use Case button, and we have a successful common use case invoked in our log. To run Koin in iOS application, we create a DI package in the iOS main directory. We create an init Koin file in the DI package. In the init Koin file, we create an init Koin function to start the Koin application and pass the common modules and any other iOS platform modules that we have. We don't need to pass any context. The reason we create the init Koin function is that we need to call this function in Xcode. Also, at the end of this video, I will talk about injecting Swift code to KMP, and this step will be important, so stay tuned. To open the iOS app in Xcode, we go to the iOS app directory, iOS app Xcode project, right-click, open in Xcode. In the Xcode project, we open the iOS app file. First, we need to import the Compose app to Xcode. To do that, we may need to build the iOS app a couple of times by pressing Command B. We need to create a delegate class and call the initKoin function inside of it. We type the name of the file where we have the initKoin function along with the extension. In our case, it's initKoin KT. The initKoin function is renamed into doInitKoin. We register the delegate class in the main app block. Now we go back to Android Studio and run the iOS app in the simulator. We click on the Invoke Common Use Case button, and we see the common use case invoked in the log. If we have a class or use case that we need it to be platform-specific, we can create a common interface or use Kotlin multiplatform's expect actual declarations, which we will discuss later. For now, we will create an interface in the common code and implement it in Android, desktop, and iOS. In the common main, in the domain package, we create a platform use case interface. The interface will require the invoke function to be implemented. We go to the view model and pass the platform's use case as a parameter. We create another function in the view model that will call the platform use case invoke function and will call it invoke platform use case. We go to the app composable and create another button that will call the invoke platform use case function from the view model. To create the Android implementation, we go to the Android main directory and create the domain package. In the domain package, we create the Android platform use case implementation. In the invoke function, we will print a message that says Android platform use case invoked. We create a DI package. In the DI package, we create the Android platform module and create the platform use case singleton using another Koin provided function called single. The single function binds the platform use case implementation to the platform use case interface. We add the Android platform module to the start Koin function in the application class. We run the application in the emulator and click the invoke platform use case button. We see the Android platform use case invoked message in the log. To implement platform use case in desktop application, we create the domain package in the main desktop project directory in desktop main. We add the desktop use case implementation in the domain package. We print the desktop use case message invoked in the invoke function. We create a DI package and add the desktop platform module to it. In the desktop module, we create a singleton of the desktop implementation class and bind it to the platform use case interface using the single function. We add the desktop module to the start Koin lambda. We run the desktop application, click the invoke platform use case button, and we have the desktop use case invoked message in the log. This may seem similar to the Android implementation, but remember that each platform might have different requirements to implement the same use case. To implement the platform use case in iOS, we have two scenarios. The first scenario is that we need regular core iOS libraries that are available in Kotlin multiplatform libraries or some third-party libraries that we want to use. In this case, we implement the use case in Kotlin like we did with other platforms, and we pass the platform module as usual. We create the domain package. We create the iOS platform use case implementation and print iOS platform use case invoked. In the DI package, we create the iOS platform module and bind the implementation to the interface. We pass the iOS platform module to the modules function in the start Koin function. We run the application in the simulator and click the invoke platform use case button to see the iOS platform use case invoked message in the log. The second scenario is if we have a code that we need to write in Swift for some reason. We will encounter such a scenario, and it is important to know how to handle dependency injection from Swift to KMP, especially when we're using shared UI. Now we will see the benefits of using the initCoin function that we created for the iOS platform. We go to the DI package and change the iOS platform module variable to a function. The function will have a parameter, we'll call it Swift implementation, that will be of type platform use case interface. We create a singleton of the parameter using the single function. We add the same Swift implementation parameter to the initCoin function and pass it to the iOS platform module function. We switch to Xcode to create the Swift implementation class. We print Swift use case implementation invoked message. We may need to build the iOS application a couple of times by pressing Command B for the code to update. We pass the Swift implementation to the initCoin function in the application's delegate class. We go back to the Android Studio and run the application in the iOS simulator, we click the Invoke Platform Use Case button, and we have Swift Use Case Implementation Invoked message in our log. Thank you for watching until the end. I hope that you've learned something new in this video. Finally, سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.